Trigonometry is simply a branch of mathematics that deals with the relationship that exists between angles and sizes of triangles. It concerns itself with the function of angles such as the cosine, sine, and tangent. Now, trigonometry was developed to solve problems in astronomy and geometry, and as a result today, we can find the height of a building without actually climbing it, or we can also find the width of a river or a road without actually crossing it. Now, this knowledge of trigonometry is mostly used by architects, surveyors, engineers in their work. But today we get to study trigonometry in detail. First, let's look at the introduction. Like we said earlier, trigonometry is simply a branch of mathematics that will deal with the relationship that is existing between angles and sizes of the sides of a triangle. And as far as trigonometry is concerned, we deal with trigonometry when we are dealing with right angle triangles. In our picture, we see a triangle which is right angled. It's right angled because it is having two of its sides meeting at 90 degrees. And we are having an angle theta. So in naming these sides of this triangle, we find that the longest side is always the hypotenuse. However, on naming these other sides, whether one side is opposite or one is adjacent depends on the position of the angle theta, that the angle we are interested in finding. For example, if you look at this angle theta, this side is opposite that angle theta. That is why this side is labeled opposite O. And this side is adjacent to that angle theta. That's why we call this line or this side adjacent. Now, what if this angle theta is situated up here? How will the naming or how will the nomenclature of this be affected? When the angle is up there, the theta we are looking for, or the unknown angle, it means that this line down here will become the opposite, because as you can see, this line is opposite that angle. So this is opposite, and it is this line that is adjacent to that angle theta. The hypotenuse, like we had earlier said, is the longest, and it will maintain its name, the hypotenuse. When we are trying to find these trigonometrical ratios, we use an acronym we shall call SOH CAH TOA. SOH CAH TOA. SOH CAH TOA simply means sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, tan is equal to opposite over adjacent. Just like we are seeing, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. It is the same even in our next diagram. We still follow SOH CAH TOA to find those unknown angles and sides of a right-angled triangle. We'll go straight to try some examples to illustrate this. Find the value of the unknown below. We have an unknown side here, we have an angle, and we are having 15 centimeters there. This is the hypotenuse. So to find this value of r, of course, we'll quote SOH CAH TOA. That's what we shall use. So now of these three, which one should we pick on? If we look at this, we have an angle here, theta. We have the hypotenuse. So we have the hypotenuse. We have this r is adjacent to angle theta. So it is adjacent. Then we also have the angle theta. So now we have the hypotenuse and the adjacent. So what can we use to find? We choose from these three. What should we use? Sine? Should we use cos? Should we use tan? Now if you look, we have adjacent and hypotenuse. If you look through here, we only have adjacent and hypotenuse right there. So it means we are going to use cos. Cosine of this angle is going to be adjacent over hypotenuse. So we shall say cosine of angle 40 is going to be equal to adjacent, the adjacent one, which is the r we are looking for, over the hypotenuse, which is 15 centimeters. And when we make r the subject of the formula by multiplying 15 on both sides, this goes with that, We remain with our value of r giving us 15 times the cosine of 40. And the answer we get there will be 11.5 centimeters. We are having a right angle triangle. We have this angle, and we realize that this value b that we want is opposite that angle. So we have opposite, and now we also have the longest one, which is the hypotenuse. So from our SOH CAH TOA, what can we use? So we have opposite and hypotenuse. If we come and look through here, we have opposite and hypotenuse right there. So it means we are going to use sine. Sine is equal to opposite over hypotenuse. So we shall come down and say that sine of that angle, which is 70, is going to be equal to our opposite, the opposite over the hypotenuse. Our opposite is the opposite is b, which we are looking for, over the hypotenuse, which is 250 meters. This is all going to be equal to sine of 70. So when we make b the subject of the formula, in this case, we shall end up with our value of b giving us 250 times the sine of 70. And our answer here is supposed to be 235 meters. We do one more. We are still going to use, it's a right angle triangle, so we are still going to use trigonometry to sort it. We have this angle 30, and on this angle, this is the hypotenuse, which is 320. So we have a hypotenuse that is labeled. Now we are having this side C. This side C is adjacent to the angle 30. So it being adjacent, so we also have an adjacent. And then we have the angle. So now what can we use to find the value of C? We have the hypotenuse and the adjacent. If we look through here, we have hypotenuse and adjacent right here. So it means we are going to use cos. So we shall say cosine of 30 is going to be equal to adjacent, our adjacent, which is C, over the hypotenuse, which is 320. So our C, making C the subject of the formula by multiplying 320 on both sides, our value of C is going to be equal to 320 times the cosine of 30. So 320 times the cosine of 30 gives us 277.1. That's our answer. Right there is a number for you to try out. Please remember to share this video in other video sharing platforms, and also subscribe and hit that like button. Thanks for watching, and this is Arnold Rangakuramya for Kisembo Academy.